Hi, this is Jacob Mays from SPSSVideoTutor.com, and today I'm going to teach you how to perform and interpret a one-sample t-test in SPSS and the Windows version of R. Now, I'm going to have them both open simultaneously side by side so that you can see how to perform both tests using both of the softwares. And the reason why I'm doing that is because it's easier to interpret the output in R when you're looking at the output in SPSS because it's much better organized than it is in R. All right, so let's start. In this tutorial, you will learn what a one-sample t-test is and when it's used. You will also learn how to open an SPSS data file in SPSS and R for Windows. You will also learn how to perform and interpret a one-sample t-test in SPSS and R for Windows. Now, a lot of people don't know, but R has an actual Windows version. Most people use the script version of R, where you just have to type in all the code, but there's a Windows version, and that came out not too long ago, and I'm going to focus on teaching the Windows version because you can do so many different analyses and tests with it. It's very powerful. All right, so what is a one-sample t-test? A one-sample t-test is used when you want to determine if there is a significant difference between a sample mean and a test value. Okay, so the test value can be the known mean from a population, or it can be the value used to compare against the sample mean. Okay, now to run this analysis, you need to know the population mean or test value, as this will be input into SPSS and R manually. All right, now in the example for this tutorial, we want to know, is there a significant difference between the average number of student absences for a particular school and the average number of student absences across all schools in the entire state in the US? We'll say New York State. Okay, now so let's actually do this. All right, so here we have, on one side we have R, and on the other side we have SPSS. So we have R over here and we have SPSS over here. So SPSS, we have the data view and the variable view, right? So that this is the data editor. Okay, this is one window, and then we've got the output viewer. Okay, the data editor, then the output viewer, and then on this side we have what we call the script window in R and the output window in R. Okay, all right, so now what we're going to do is we're going to open up the data file. So we go to File, Open, Data. Okay, and then we're going to go to the specific data file, SPSS R workshop, mini workshop number one sample t-test, and we're going to select the one that says one sample t-test SPSS. And we're going to click open, and this is our data file. Okay, this is the number of absences for all the students in the school. Now, this is a small school. We're going to call this the small school because this school only has 18 students. Okay, so you know, typically in the US, you know, there are hundreds if not thousands in a high school or any school, but this school only has 18, so we're going to call this the little school. Okay, and we're going to compare this to all the other schools in the New York State, the 10 schools. So now we're going to open up the data file in R. So we go to Data, we go to Import Data, and we go to SPSS Dataset. And the reason why we're doing this is because it's an SPSS data file. So we're just gonna, it asks us to create a name for the data file. It's just something that we do in R. So we're just gonna call this one sample T. It says convert character variables to factors. That just means that if your variables are in written form, like male, female, it will convert them to 1 and 2. Okay. First column contains rows. We don't have to worry about that. Convert variable names to lowercase. Now this variable name has a capital first letter. Sometimes that causes problem in R, so we want to check this. Convert variable names to lowercase. So in R, this is going to be lowercase a, b, s, e, n, t. And then we click OK. Oh, we can't have dashes. Same thing with SPSS. We can't have dashes. So we're just going to call this one underscore sample T. Okay. So same thing with SPSS. You can't have dashes. You have to use underscores. So we're going to click this, and then we're going to click OK. And then we're going to select one sample T for R. And then there we go. And then if we want to view the data file, we click on edit, and we see that the data file is there. Okay, so we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way down to 18. And this is the row named like this is here, 1 to 18. And then we've got 39, 31, 25, 39, 31, 25, 52. So all the values here are the same values here. Okay. Now, so we want to run a one sample t-test. So we go to analyze, we go down to compare means, and then we go to one sample t-test. Okay. Now we're going to say that the average number of absences across the entire state is 15. Okay. So essentially, across all the 10 schools, the average number of absences across the student body is 15. Okay, 15. Now, so what we want to do is we want to determine if our test value, the average number of absences across the schools, all schools, is significantly different than the average number of absences compared to the little school. Okay, so we're going to put absent here because these are the number of absences for each student. And then we're going to calculate a mean, and then we're going to compare this mean to this value, which is the state average. Okay, and we know that because we've done the calculations, or we got it from a report or something like that. Okay, this is something that we just pulled from some other form of data. We didn't calculate this 15 value. We actually pulled it from somewhere. Okay, that's why they call it a test value. It's not something that you calculate. You pull it from some source and you're just comparing it. All right, so we go to options, 95% confidence interval, and everything else is going to be left right there. All right, so if we want to run a one sample t-test in R, we go to statistics, we go to means, single sample t-test. Now, all right, so here, the first thing we need to do is we need to select the variable in question. Since there's only one variable, it automatically selects. Now in R, you're not moving a variable over to any box, you're just selecting it. And you select a variable, you know you selected a variable because the background turns blue. Okay, now here we have to select what kind of statistical comparison we want to make. Do we want to evaluate whether the population mean is significantly different from the test value, whether it's higher or lower? Or do we want to test whether the population mean is significantly less than the test value? Or do we want to test if the population mean is significantly greater than the test value? Where SPSS automatically defaults to whether there is a significant difference, right? It tests the null hypothesis, meaning is there a difference whether it's higher or lower? So we're going to keep with the same protocol as SPSS. So we're going to type this there, just like we did over here, 15. We're using the 95% confidence interval, just like we had over here. And then we're going to click OK. And then we're going to click OK. Now, here we have the one sample t-test. We have the n, the mean, standard deviation, and standard error. And then we've got the t-value, degrees of freedom, the p-value, the mean difference, the 95% confidence interval, lower and upper level. And then in R, we have the t-value, okay, 5.075, 5.077, and this just goes a little bit further into the decimal point, so 5.0775, which actually rounds to 5.078. Degrees of freedom 17, degrees of freedom 17, p-value. Now SPSS, it only goes to 3 levels or 3 decimal points. So if you see 000, that means p is less than 0.001. Whereas in R, it actually gives you the p-value. And we would write this in our report as p is less than 0.001, because anything lower than 3 zeros in the decimal places, we always automatically write via APA rules that p is less than 0.001. Now, so it says here, alternative hypothesis, true mean is not equal to 15. So here, because this was less than 0.05 here and here, that means there's a significant difference between our test value and the mean of the little school, which is 29.44. Okay, now use the 95% confidence interval. Now what you will notice here is that the 95% confidence here interval here is different from the 95% confidence interval here. So let's take a look at that. But actually they're the same, and let me show you why. So let me just clear this up. Now, so let's say we have the bell-shaped curve. So, and this is the mean. And we've got 29.44, 29.44. And then we've got the upper level, call it UL. And then we've got the lower level confidence interval, LL. Now, here it says 23.44. 23.44. And then here it says 35.44. 35.44. Now, here though, we're evaluating the mean difference. Okay, so what SPSS does is it calculates the mean difference and then uses this as the mean, and then it develops the confidence intervals off this. So you subtract 15 from 29.44 and you get 14.44. So if you subtract 15 from this, you get 14.44. And then you would get the upper level. So if you subtract 15 from 35.44, you get 20.44, because that's it. They just subtracted 15, the test value, from all of these. So if you subtract 15 from 23.44, you get 8.44. So that's why there's a difference. But it's easily understood because the mean difference is used as the mean here. Whereas here, the mean was actually 29.44. That's the only difference. R doesn't use the mean difference. It uses the actual mean. Now, one of the things you will notice about R is that there are no descriptive statistics. So in order to do that, you actually have to run an additional procedure to get the descriptive statistics. So you go to Statistics, Summaries, and then Numerical Data. You click on Absent, you click on Statistics, you select Mean, Standard Deviation, Standard Error of the Mean, let's see, in mean, standard deviation, standard error of the mean, and that's all you need. And then you click OK. And then now we have that. So now we have a mean here of 29.444. We've got the standard deviation of 12.06952 right there. And then we've got the standard error of the mean, which is 2.844. And then you've got the n, which is 18. Now, one of the things you're going to notice as we go through more of these tutorials with R is that in SPSS, each statistical procedure will generate descriptive statistics, whereas in R, descriptive statistics have to be run separately. Okay, so just keep that in mind. You have to run descriptive statistics separately in order to get that. All right, so that is essentially how we perform and interpret a one sample t-test in R and in SPSS. Now, what I'd like to do now is I'd like to share with you some information about a workshop that I'm doing with R, okay, and SPSS. I'm doing it the same way, and I'm teaching you all of the various statistical procedures in R through small chunks. I call it the SPSS to R mini workshops because these mini workshops are about 1 hour to 90 minutes long. Okay, so let me just take some time to sort of explain this to you. All right, so I call it the SPSS to R mini workshop series. How to perform and interpret statistical procedures using the Windows version of R. And again, it's going to be SPSS on one side and R on the other. All right. Now, before I begin, if you like the tutorial that I just shared with you, click the like button. I'm just going to pause for like 30 seconds for you to click the like button. All right. Click the like button, please, so that the algorithm, the Facebook algorithm can share the information with other people. So please click the like button. All right, great. Now, who is this workshop series for? Graduate students who want to learn Windows version of R, for professionals who analyze quantitative data who want to learn the Windows version of R. And again, this is an emphasis on the Windows version. There's not going to be any code. I'm not doing code because I'm not doing that. That's just too much work. And nobody wants to learn code. That's why R hasn't been widely adopted in the social sciences by a lot of people, because, and the business sciences and things like that, because no one's trying to type code. Once people learn about the Windows version, R is going to explode. So this is really an opportunity for you to sort of get ahead of the curve. All right. It's also for SPSS users who want to learn R. And it's ideal because, again, I'm teaching all of the procedures in R with SPSS open on the opposite side. And then finally, anyone who wants to learn the Windows version of R. All right. So what do we cover in the workshop series? We conduct these mini workshops to help students and professionals learn the Windows version of R. Again, this emphasizes Windows version, and we do it in small, manageable chunks of 60 to 90 minutes. Okay. And essentially what we're doing is we're going to cover how to perform and interpret various statistical procedures in both SPSS and R. Now, some of you may know my website, spssvideotutor.com. I have like over 40 different tutorials on how to perform statistical tests in SPSS. I'm going to mimic that in R so that you can go to the Windows version of R and be able to run all of those statistical tests using R. But I'm doing it in smaller chunks. I'm doing it in the workshop. All right, so there are going to be several workshops where I do this. And the analyses are performed side by side in SPSS so that you see the similarities and differences in the process, as well as it's just easier to interpret the R results because, as you can see, they're just sort of all jumbled up. Whereas SPSS is very clean. Again, you don't need to have SPSS installed in your computer. It's just for visualization purposes. All you need is R for Windows, and it's free, right? Because it's open source. So, unlike SPSS that, the licenses expire and so on and so forth, you don't have to do that with R. Once you register and download, you're all set. Now, once you register for the first workshop, you will receive a video that shows you how to install R on your computer. All right. Now, how much did you learn about R by just spending 15 minutes with me? Just 15 minutes. That one demonstration took about 15 minutes. How much more could you learn about R for Windows by spending an hour with me, right? In just a short time, you could become very proficient using R, because as you can see, it's not that hard. SPSS to R mini workshops are on demand, so you can watch them whenever you want, right? 24 hours a day, 7 days a week, they're available. The basic mini workshop registration fee ranges from $47 to $97. So it's minimal. The fee is extremely minimal. Like I said, for like a 60 to 90 minute, $47 to $97, that's nothing. And R is the future. So it's really critical that if you're in the data analysis field, or you're going to be doing data analysis, that you really learn R, because it is the future. So click to learn more about how you can start learning R for Windows today. Okay? Click the button, learn more, and then you can get started learning today. All right? If you have any questions, just post them inside the comment section and I will respond. Thank you so much. Again, please like the video and register for the first workshop. And then as new workshops are produced, I will let you know, and then you can take those workshops as well. All right. Thank you for your time and attention. I'll talk with you soon.